Right, so we just finished up talking about quadratic functions. Now we're going to talk about another couple type of functions called power functions and polynomial functions. A power function is a monomial function of the form y equals ax to the n. And monomial means it just has one term, like this. So it just has one thing. It'll be like 2x squared, or 4x to the fifth, or 3x to the third, something like that. A polynomial function, so a polynomial function is a function that has multiple terms. So polynomial just means it has multiple terms. Wouldn't worry too much about all this that you see here. Just know that this would be the nth term. This would be the n minus 1 term, and it would go all the way down until we got to the second term, first term, and the 0th term, which is the one that doesn't have an x to it. So don't worry too much about all that right now. The highest power of a polynomial is called its degree. So if you see something that's like x to the cube plus 5x squared plus 2x, well, this is the highest power. So the degree is 3. If you see one that's x squared plus 2x plus 1, well, that's degree 2. It's the highest power. So something to keep in mind about the graphs of polynomial functions is polynomial functions are defined and continuous for all real numbers and have smooth rounded turns. So they're always going to be like this. They're going to be the kind of things you can draw without ever picking up your pencil. They're never going to have jumps in them. They're never going to have sharp turns in them. So they're always going to be just these smooth, continuous curves. And they're going to be for all real numbers. So that means their domain is negative infinity to infinity. So there's a couple of main characteristics that we can determine about polynomial functions and power functions. And it can help us graph them without a calculator. So there's end behavior, zeros, multiplicity of zeros, and y-intercepts. And we'll talk about those real quick. So first thing we'll talk about is end behavior. And you've kind of already seen that. And so what we have in this little table here, LC stands for leading coefficient. So what we have in this little table is it says if the degree is even and the leading coefficient is positive. So this is a way we're going to learn what the graphs look like. Whenever that happens, so you have like an x squared because it's even, and the leading coefficient is positive, so it's like 5x squared. It's going to look like this. The ends, and remember we're only talking about the end behavior. Both the ends are going to go the same direction, and they're both going to go up. If we have a degree that's even, again just like this one, but the leading coefficient is negative, so like over here we see negative 2x to the fourth. Well, that's even with a negative leading coefficient. Both the ends are going to go the same direction, but they're going to go down. Okay, then when we have an odd degree polynomial, odd degree, the ends are going to go different directions, and when the lead coefficient is positive, it's going to start low and end high. So when we have an odd degree polynomial that has a negative coefficient, it's going to start high and end low, kind of like that. So real quickly, these two examples say describe the end behavior of f of x. Well, the way we describe the end behavior, we know this one is this picture right here, even degree, negative leading coefficient. So we say the limit as x goes to negative infinity of f of x equals, well, as x goes towards negative infinity, this graph goes down, so it goes towards negative infinity. And then we have the limit as x goes to positive infinity of f of x, and as x goes towards positive infinity, it also goes down, so that's also negative infinity. Okay, take a look at problem B. F of x equals 5x cubed. So that's an odd number, odd degree, so that's here or here, and our leading coefficient is positive. So our limit x goes to negative infinity of f of x. So as we go towards negative infinity, it's going down, negative infinity. And our limit as x goes to positive infinity of f of x. As x goes towards positive infinity, our graph goes up, so positive infinity. Okay, a couple other things that you're used to is zeros. Other words for zeros are solutions, which will look like x equals 0. You'll have roots. They'll also say x equals 0. And you might have x-intercepts, and they'll be written like a point like this. So these are just examples. They're not, don't memorize any of this. It's just showing you what they would look like. So find the zeros of f of x. Well, to find the zeros, you set your equation equal to 0, and you solve it. So we can take out a negative 2x squared, and we're left with x squared minus 4. And we keep going, negative 2x squared times x plus 2, x minus 2, and then we can also divide both sides by negative 2, and that would make this negative 2 just go away. So now we'll have x squared equals 0, x plus 2 equals 0, x minus 2 equals 0. So our zeros are x equals 0, x equals negative 2, and x equals 2. Okay, something that we're going to learn about is called multiplicity, and you see it underlined here. And there's a description here of it, but just let me explain it to you real quick. Multiplicity means how many times a certain factor shows up. So this factor, x minus 2, it just showed up one time. So it has a multiplicity of 1. X plus 2 showed up one time, right? So it has a factor of 1. But this x down here, right? It really shows up 2 times because we have x equals 0, but then we'd have another x equals 0, but we don't need to write it because you don't write it when it equals the same thing. But this x shows up twice, so this has a multiplicity of 2. And it's hard to read right here, but it says if a 0 has odd multiplicity, so that's these two, right? Then the graph of f crosses the x-axis at x equals c, and the value changes signs at x equals c. So what that means on a graph, like this graph specifically here, is when x equals 2 and x equals negative 2, this graph is going to go through those points. It may go up, it may go down, but it's going to go through them. And down here it says if a 0 has even multiplicity, then the value of x, the value of f of x, does not change signs. So that means right here at 0, if this graph is coming up, when it hits here, it's going to go back down and stay in the negative. Okay, and what this is going to look like when we see this, negative for the start, okay, remember, let's look back up. We have a negative leading coefficient and an even degree. So leading coefficient's negative, even degree, it's going to start down, and it's going to stay down. So that means we start down, and we go through this. Now, we know that we're going to have to go to this, so at some point, this graph is going to turn back down. And when it hits here, it's going to bounce back up. At some point, it's going to turn back down again and go back through there, so that we wind up both sides going down. It crossed at these 2 points, and it bounced at these 2 points. And so when our factors, if x minus c is squared, or to the 4th, or to the 6th, or any even number, it bounces. And so on a little sample of a graph, that would look like this. Hit it and come back down. If our x minus c is an odd number, then it crosses. Okay, and so that might look like that, right? So right there is our c, right there is our c. And so that's kind of what we can learn about those degrees. All right, so we're going to factor these two functions, and we're going to state their multiplicity. So negative 2x squared times x minus 4. We can just drop the negative 2. This is really the same one we just did. So this is a factor, this is a factor, and x squared is really x times x. So our factors here are x plus 2, x minus 2, and x squared. So this is a multiplicity of 1, multiplicity of 1, and a multiplicity of 2. We'll come over here and do this one. We get x plus 2 times x minus 2, multiplicity of 1, multiplicity of 1. So on our graph, this is going to cross at negative 2, this is going to cross at positive 2, cross at negative 2, cross at positive 2, and we're going to bounce at x equals 0. And we'll practice it, so don't worry about it too much. All right, something else that's interesting is that turning points are the points that a graph either changes from increasing to decreasing or decreasing to increasing behavior. So if you think about a graph like this, as we move along this graph, when we get to this point right here, that's a turning point. The graph has changed from decreasing to increasing, and it happened right at that x value. And then here it changes again, and here it changes again. So these x values right here, these are turning points, and we'll learn how to find those pretty quickly. Just remember that a polynomial function has at most n distinct real zeros and at most n minus 1 turning points. So what that means is whatever this number here is, the highest degree, that means it has 6 real zeros at most, and it has 5 turning points. All right, so let's take a look at this one. It says we have f of x equals negative 2x to the fourth plus 8x squared. We've seen this one several times. And it tells us to apply the leading term test, find the zeros, determine the multiplicity, find additional points between the zeros, and then graph it. So all without a calculator. So the leading terms test just asks us to look at that leading term, negative 2x to the fourth, and we say that it's an even degree, and the leading coefficient is negative. So even degree, and our leading coefficient is negative. So we know that means that the limit as x approaches negative infinity of f of x is going to equal negative infinity, and that the limit as x approaches positive infinity of f of x is also going to equal negative infinity. And so that just means that our graph is going to be going down and down when we finally draw it. All right, so let's go on to B. Find the zeros. Well, we've done this a couple times with this one already. So 2x to the fourth plus 8x squared equals 0. We get negative 2x squared times x squared minus 4. Again, we've done this one several times. So x squared times x plus 2 times x minus 2 equals 0. So our zeros are x equals 0, x equals negative 2, and x equals 2. Okay, part C says determine the multiplicity of each factor. Well, this one's a multiplicity of 2, right, because there's 2 x's to make the x squared. This is a multiplicity of 1. This is a multiplicity of 1. So that means this is going to bounce, cross, and cross. Okay, it's crossing because it's odd, and it's bouncing because it's even. Now we're going to move over here and look at part D. So D says find additional points between the zeros. Okay, well, so x and y, that means find points, right? So we know the zeros are negative 2, 0, 0, 0, and 2, 0, right? We got that from right here. So we're going to find points in between them. So negative 1 and 1 are in between those. So we plug negative 1 in here. So it's negative 2 plus 8, which is positive 6. And then we do 1, we get the same thing, positive 6. And so now we know on our graph that we're going to cross it here, we're going to bounce here, and we're going to cross it here. So when we put all these points, negative 2, 0, negative 1, 6, 0, 0, 1, 6, and 2, 0, we know that we're going to cross here, we're going to bounce here, we're going to cross here, and we need to start down low. So we're going to start down low, go up here. I don't know if this is exactly where we turn, but we're going to turn somewhere. Bounce there. We got to come back through this to go off that way, and that's not a very good. All right, that's not much better, but you get the idea. All right, so that's it for today. Come in tomorrow and we will practice this.